Hi everyone, welcome to week 3. We've got a bunch of exciting things lined up for this week, including an introduction to trigonometry, which starts from day 2. But before that, let's revisit a couple of things that we have talked about before and look at certain ways of finding information about these shapes. The first of them is called a sector. Recall that the sector of a circle is a figure formed by two radii and the arc intercepted by the radii. Here in this diagram, the shaded region is a sector. So there are two characteristic features for a sector. What it means for something to be characterized by and you list a bunch of things. It means, let's say you are on the phone and you're trying to communicate an information about a shape. What are the minimum number of things that you need to provide information about in order to have that communication? So for example, if you think of a circle, all you need is a radius. A circle of radius 10 centimeters is pretty self-explanatory. But for a sector, you would need the radius and you would need this angle theta, which is the central angle. This symbol here, that's a Greek symbol used often in mathematics, and it's written as theta, however you want to say it. It's just a convention that we use this as a variable for angles, just as you would use x for an unknown number. So this means that given r and theta, you can communicate information about a sector. Now we've already seen this before. What's new today is that we can find the area of this sector, and that area is given by theta over 360 degrees times pi r squared. Now this should look familiar. This is a circle's area, right? The area of a full circle is pi r squared. Now, why is this the area formula? Hopefully you thought about it a little bit before you look at the video. The area of the circle is pi r squared. Now, what ratio of the circle does the sector occupy, say? Now, if you look at it, a full circle is 360 degrees and the sector occupies exactly theta out of 360. And this ratio is theta over 360. And so the area of the sector is just giving you what ratio of the full circle the sector is. For example, if theta is 180 degrees, then what you get is a semicircle, right? This is a semicircle. So it makes sense that the area would be in proportion to whatever the value of theta is. For example, find the area if the radius is given to be 84.25 feet and the central angle is 135 degrees. So just make sure this is in degrees and you go 135 divided by 360 times pi 84.25 squared on your calculator, which when I plug in, again remember, whenever doing calculations involving pi, use the pi button on the calculator. 84.25 times 84.25, and that you should verify that it comes out to 8,362.21 square feet. This unit is important. The unit is always going to be in square when you are working with areas. All right, let's look at another example. It says a vehicle windshield wiper swings an arc of 140 degrees. The wiper is 11 inches long with a wiper blade of 8.5 inch. Assuming the windshield is a plane surface, find the area swept by the wiper blade and round to two significant digits. So let's first make a diagram. So let's say that's my window or my windshield. which it says we can assume is a plane surface. Now let's say this is where my wiper is at, right here. But remember that the wiper is 11 inch, but the wiper blade is 8.5. So let's say the wiper blade starts here and goes like that, and then it swings an arc to the other end where it goes like that, and let's say that's the wiper blade. So this angle is given to be 140 degrees, right? And I can find this length, that's going to be wiper minus wiper blade. Oh, sorry. This one's given to us to be 8.5 inches. And this part here is going to be wiper minus wiper blade. So this length would be given as wiper minus wiper blade, which we have the values for. So it's 11 minus 8.5, which is 2.5 inches. Now, as the wiper sweeps on the windshield, the top of the wiper makes an arc, and so does the bottom of the wiper. So what we are trying to find is this area of this shaded region. Now what you will notice here is that this area equals area of the big sector minus the area of the small sector. What do I mean by big sector, small sector? Because this shape, the shaded one, is not exactly an arc, it can be seen as the area between two arcs. The arc made by the top of the wiper and the bottom of the wiper blade. Because you have this area right here where this, let's say the dotted one, which is not getting cleaned by the wiper. Now for both these sectors, the angle is the same. So it's 140 degrees over 360 degrees, but the radiuses are different. The radius for the big one is the length of the wiper, so it's 11 squared times pi. And the radius of the small one we found is wiper minus wiper blade, and it is 2.5 squared. We plug all of this into the calculator, and let's see what we get. So we have 11 squared pi minus 2.5 times 2.5 times pi, again making sure you use the pi button on the calculator, divide by 360, and this comes out to roughly 140.19 square inches. So that is the area. Now it says round to two significant digit. So when you round this to two significant digit, it's just going to be 140 square inch. That's the rounded off value. That's the end of the first video for this day. The next video we will be talking about another shape relating to the circle called the segment.